So thanks again for being here at FutureNet. We've got a great program lined up for you today. But before we jump into the session, I'd like to tell you a little bit about sort of the idea for today's conference. We have a general theme for the conference. Now, for a long time, the primary tool, how in a data center we managed connectivity between different resources and how we segmented and secured the data center, was layer 2 to 4 networking. Recently, it has been challenged. There's a group of cloud hipsters that are basically saying, in a world of microservices and containers and platforms, you can now move all of this up to layer 7. Instead of establishing a basic connectivity fabric, we now have a service mesh. Instead of having a border firewall, we can do this with an API gateway. And in fact, in many cases, we may not have any choice anymore rather than to do it that way, because if I look at the layer 2 to 4 networking in a data center, all I see are SSL connections or TLS connections between various services and API gateways. There's really no more meaningful information about the topology of how information flows in these kind of networks. So to kick this off, we got 3 great talks about the technology stack that's used. We're going to kick it off with Louis Ryland from Google talking about service mesh, the fabric, so to speak. Then we have Marco Palladino from Kong talking about API gateways. And last but not least, we'll hear from Netify about how to do congestion control for these type of connections. We're sort of reinventing TCP at layer 7. And with that, I'd like to welcome on stage Louis from Google.
Everybody. I'm from Google, and we do some things at Google a little differently than maybe most of you are used to doing in the enterprise. And so I'd like to talk about how some of those technologies or some of those principles we're trying to make available to the community in general via an open source project called Istio. So Istio is a service mesh. It's a cool buzzwordy term with Flash graphics. But one thing that I get asked an awful lot is, okay, that sounds great, but what actually is a service mesh? So when I think of a service mesh, I think about 3 things. I think about elevating the network to the needs of applications. And I don't just mean writing applications to kind of fit the network model, whatever your network model might be, but also to all the applications that you already own today, right? Because if you're running a large IT organization, you probably have a large inventory of applications that were written over a long span of time. We want to make sure that you have good information about the behavior of those applications, because they're all talking to each other. And not just information in terms of bandwidth or CPU consumption, but in terms of their actual relationships, their contractual relationships at an API level. Right. There really is no such thing as a protocol that is not a layer 7 protocol. Right? Every protocol exposes an operation. That operation has a semantic meaning. Right? The number of operations a service can provide to another service in the network is the thing that defines the SLO or the SLA of that service itself. And you want to be secure. And security means a lot of things. We've talked a lot, or I hear a lot about VPC boundaries or VPN boundaries as the modality of security, the modern modality of security. As the world becomes more diverse, right, we talk about hybrid cloud or multi-cloud, and we also talk about multi-platform, or maybe you're running workloads on a combination of Azure Service Fabric and Pivotal Cloud Foundry, and you're running some of it on-prem and you're running some of it in the cloud. How do you secure all that stuff when your topology is really diverse, right? How much expertise do you have to be able to ensure consistent security policies across these rapidly evolving environments? So we're trying to help you with all these problems in a way that also doesn't necessarily cost you an awful lot of money to implement, because one of the things I've had experience with, I worked on building out gRPC, which is this nice protocol, Google open source, that gives you a lot of these properties, but gives you them in library form. And the first thing that we found when we released gRPC is, well, that's great, but now I have to go and rewrite all of my applications to get these properties. That's more expensive than I can bear. Right? So how do we do this? Or what are we trying to do? So let me tell you a story about modern application development, or even just say legacy application development. Spent about 15 years writing Java code. And so I would write code that looked like this. All right? And I'm smart, so the network fails. I'm aware of the fallacies of network computing. So I'm going to go and I'm going to do something internally. I'm going to fetch some important internal piece of information. I'm going to do some work with that information. And hopefully that work makes me money. Right? The goal of businesses. Sometimes it will fail. And I guess the fallacy of network errors is usually when things fail, intervention is needed, and that intervention is not automated. Right? Please help me. Wave, hey sysops guy, why is the network down? What's going on? Right? I basically bail. But this isn't exactly a very reliable system. There's lots of things I need to do to make network communication more reliable. Right? I'm still not going for perfection because perfection is impossible, but this needs to work more often than this code would suggest. Right? So maybe, when I go and fetch secret sauce, there's lots of different implementations of the service that provides secret sauce. So I probably want some form of service discovery or load balancing, right? So I'm going to go and I'm going to look up an SRV record that's got a whole bunch of endpoints for my service, and I'm going to pick one, and then I'm going to make my HTTP client talk to it, and then hopefully, in a distributed network of consumers, this works better. This, by the way, is terrible code. Please don't do this. But I've also written this code, so I have done this, and I know what happens afterwards. All right, so that didn't quite get me to my SLO. Let me start retrying. This is even worse. Starting to get, I'm showing you the pathological worst cases of people writing networking code, but people do this all the time, and I've done this. We can talk about the vagaries of random and PRNGs and how I generate thundering herds, but this is really bad, right? But I, as the developer, have done this type of stuff. And I'm going to do something even more evil, right? Well, that secret source service, it's important, right? Nobody should be able to access it except the things that should be able to access it. And I've been granted that authority, so somebody gave me a key file, and I put it on my server, and now I read it, and I stick it in a header, and I send it, and the service validates it. Great, I'm secure. Except, obviously, that key material is in a place that, if anybody could penetrate my software, that key material is immediately exposed. Right? It's a bad idea. Plus, it also doesn't do anything for me. Right? All this does is tell the secret sauce service that I have the rights to access them. It doesn't tell me who the secret sauce service is. What if somebody spoofed the DNS? Right? I don't actually know that I'm talking to the secret sauce service. I could be talking to the evil sauce service. That's really bad. Right? So in a world of modern security threats, right, all these types of things do happen. Right? Some of them are self-inflicted. I've blown off my foot with retry logic. I have dealt with many of those cases in production at Google. These types of things happen. And this code is everywhere. Right? I've done it. I'm willing to bet most of you have done it. And we're going to keep doing it. And it's bad because when I looked at the original code, right, it's fairly straightforward what it's trying to do. Right? It's focused on the business logic. It's focused on the domain, the problem I'm trying to solve. I'm trying to make money from my secret recipe. But I had to put all this other stuff in there to make it reliable. And that stuff is brittle. It's expensive, and there's more of it than my business logic code. That's not a good return on investment. So what do we do? Well, we should probably monitor the system. Great, okay, I put my monitoring in place. This is also terrible monitoring, right? It's giving me very, very little information about the behavior of the system. And if I wanted to get lots of information about the behavior of the system, that amount of code would explode even more than this. Right? I'd have to look at different aspects of the HTTP request protocol. Maybe there are DNS lookup issues. All kinds of issues could show up. It would be very expensive for me to write that detailed instrumentation for that code. So again, more tax, lots more tax. And it gets worse. Right? This is my beautiful code. right? It's sleek, it's efficient, it's shiny. I just wrote it, it's fresh, it's awesome. And I wrote it in Java. And then I wrote it in Node.js. And then I went and wrote it in PHP. And then I went and wrote it in ASP.NET. And then I went and wrote it in something else. And maybe I'm super cool, and I go build a framework within my organization so we could all share that code. Awesome. Lots of shiny fish. Time passes. Even more fish. The folks who wrote that code, they went away, they did other things, they built other fish. The fish are still around, they're living in a box. I don't know if people have ever been to Sweden, but there's this stuff called surströmming, which a friend of mine introduced to me. And it's fermented herring sitting in a can. I don't know if you can really see it, but that can is actually bulging from the pressure of the air inside. It's totally safe when it's in the can. But if you want to do something to it, if you want to touch that code, it is going to explode all over you in a way that you don't want to see. There are some good videos on the internet of this. It's a guy trying to show his dogs. The dogs ran away. The cameraman gets sprayed. He runs away. It is just absolutely horrific. This is what brownfield is, right? So what are we going to do about this? You can't not do something about it, right? You still own all the software. It's still doing stuff for you. It's still part of your business value. Help? So we need to put something around this, right? Something that will at least give you some degree of control, both in terms of particularly monitoring, right? I want to understand what this software is doing. You know, maybe I need it to have better security properties. Like, how do I introduce that into a thing that I don't really want to open or touch? So we need to put a shell around it. And that's what Istio does. Its job is to kind of sit between something like this and the network and understand or be able to mediate enough of that interaction to be able to provide you those properties, right? Without opening what is absolutely horrific. So let's talk about monitoring, because usually monitoring is the kind of the first problem people try to solve. And you have all those tins, but you don't really know what they're doing. I'm going to say, look, I'm going to containerize those tins. I'm going to go stick them in Kubernetes. And you're going to get something like this. Right? You're going to get this nice dashboard. I've got all my tins listed out down here. But unfortunately, you don't really know what the tin is doing. You know how many resources it's consuming. You know how many of them you're running. You have no idea how they're interacting with other parts of the system. Right? We need something that's able to look into their interactions and extract that information for you. And that's layer 7, right? That's layer 7 networking. Right? My code was doing HTTP, that's good, okay, that's a well understood protocol. And if you look around in the industry, right, there are lots and lots of things doing HTTP. You know, it could be doing some other protocol. Maybe I'm doing WebSocket or MySQL or Transact SQL to SQL Server. Right? These are all layer 7 protocols. And so as long as you have something that can understand them, that can sit in the network path, you can start to extract this information out. And you can start to understand the contractual dependencies between the systems and the network. And you can start to use that to maintain SLOs or to manage to SLOs. And this is a very important property, right? Without understanding, you don't know how to react when systems or dependencies go wrong. Right? And so that's what Istio is trying to do. The first thing that we're trying to do is just help you understand the dependencies between your systems. So here's a slightly more useful view. This is a capture from a product that we announced recently at GCP Next. But again, I have my tins of herring. They're all talking to each other, which I could extract that information from layer 3. But on the top right, you also see rates of interactions at layer 7, right? This is a very basic view, right? We're showing you latency and we're showing you status code, right, from the HTTP protocol. And now I know quite a bit more about how my systems are behaving. Right? Let's say my recommendation service starts having a problem, maybe there are not enough instances, it's under some pressure. And that pressure doesn't show up in the CPU graph because maybe there's just some bad code inside the thing. And so I start to see lots of 500 errors, right, in that edge. And so maybe I have a different kind of response than I just go and scale up. Maybe I need to go and ping the development team. Maybe I need to go and fix the bug. Right? But I see more about what's going on. And Istio gives you the ability to do this without opening the can, right? And that's really important. And as you know more and more about what's going on in the protocol, you can have a much more refined operations practice, right? Your operators get a better sense of what the dependencies of the systems are. They have a better engagement model with developers who wrote those systems. They can provide more useful information about the behavior of those systems. And conversely, developers can describe a better contract for the operator so the operator can do more things independently. Right? They can react to the behavior of the system. Again, another extremely important property. Right? If you really want to have a modern, agile operations team that can effectively take action on systems in production. So, a good anecdote, we had a customer who rolled out Istio in production, primarily just to get this type of information out of their system. And they were having trouble with what's commonly known as a query of death, right? You have a database, there's a particular type of query that one of the clients is issuing that's causing that database untold problems. And within about 15 minutes of rolling out Istio, they were able to identify which of the clients was issuing that query and what was in that query, right? They could never have done that with layer 3 monitoring before. And they were able very quickly to remediate the problem. So again, a very small, simple example, but the types of things that layer 7 gives you. So the last thing that I'd like to talk about, and this is maybe the most important aspect in my mind, right? We talk a lot about security, and obviously, there are lots and lots of different forms of security properties. Talked a lot about microsegmentation. You probably heard a lot about it at this conference. I only showed up today, but I heard it 7 times in the podcast recording. Google is somewhat famously known for running an unsegmented network internally. Right? Literally, every machine on the network can talk to every other machine on the network in our prod network. That doesn't sound very safe, right? Or certainly untraditional. And that's because we've adopted a methodology that say, look, every workload that we have has an identity. And that identity is provenance, right? It came from some authority, right? It came from me, right? A human operator running that software in production. And I was probably granted permission to run that software in production by somebody else with even more authority, right? So there's this notion of a kind of hierarchy of authority that's tied to people, right? Or the roles that people play in the organization, right? And this is what we mean by workload identity, right? A verifiable identity that comes from an authority. And we use that identity with, PKI, right? So my authority is represented in the form of a certificate. And when I talk to another service, we mutually verify each other's certificates, right? We do a mutual TLS handshake, and we're allowed to talk. And if that system wants to enforce a policy on who's allowed to talk to them, they can simply have a whitelist of identities that are allowed who present. This represents a really important philosophy in a couple of ways. So one, I kind of referenced this mutual verification part earlier. One of the common attack modalities today is to be able to attack DNS, to inject fake DNS entries, so that I can spoof the identity of the destination service. Well, if the destination service doesn't have key material that asserts to me, right, that it is who it says it is, then I won't talk to it, right? So we have mutual verification, right? A lot of networking policy, or even in API gateways today, right? It's the verification is unidirectional, right? We don't verify both parties. The other property is that this communication form can span any network, any physical topology, without losing its ultimate property of mutual verification. Right? I actually don't care how it transits, right? It's encrypted on the wire, it's end-to-end verifiable, and I don't care where it goes. So some of you may have heard of a white paper Google published called Beyond Corp, right, which talks about doing something like this, where instead of workload ID, I mean people ID. Right? What Istio does is Beyond Corp for production networks, right? Every service gets an ID, that ID is tied to an authority, and then you can assert the identity of systems end to end. I don't know if you want to refer to this as the ultimate form of microsegmentation, but it certainly facilitates very, very precise segmentation modalities. It also makes the system in some ways much more auditable, right? I understand, based on authority, why systems are talking to each other and how they receive that authority. So that's a very useful property when you audit the behaviors of systems. You have a very nice record couched in your organizational structure, right, and not the network structure, right? I know who's responsible for what. The other nice property, or I've talked to a number of customers, one other nice property of this modality is, people use VPNs or VPCs and they microsegment, and you keep shrinking down and down and down, but that costs time, effort, and money. And so what happens is we tend to kind of figure out where we want to draw our boundaries, and those boundaries are drawn based on how much time and effort we have to put into defining that, and the resources we're trying to put in the boundary, which makes the resources that are inside the boundary less flexible, right? They can't move elsewhere. And in a world where we're trying to do all things like functions and containers and all these dynamically scalable workloads, if I lock physical compute resources into a network, I can't then move them around. Right? They become less fluid. Right? So this makes physical networking resources and compute resources and storage more fungible. And that's all that I have. I'm not going to drill into the architecture. There's lots and lots of detail, but I'll leave this slide up, and I'll let the next presenter come up and get ready. And if anyone has any questions, I think we have a couple of minutes for questions.
Maybe one question.
All right. All right, we have one. There we go, there's a hand.
So we tried to solve identity in the networking world, like IP server. Okay, that's a weird microphone. Sure. So we tried to solve identity, isolation based on identity in the networking world with IPsec. Mm-hmm. And that didn't work very well because it was very hard to manage policies at that fine-grained level, plus the overhead of authenticating each and every request was a lot of work, and so hit scale limitations. Why do you think when IPsec failed in ensuring end-to-end isolation via identity, but will succeed here?
So I think there are a couple of different things, and some of it has to do with the price you're willing to pay, right? IPsec, what was the thing it was tying that identity to, right? So, one of the major things you see right now going on is how do we orchestrate workloads, and orchestration ties into how I assert the identity of a workload. You can obviously tie an IPsec tunnel to a VM, right, and say that's your unit of identity. I think there's a couple of reasons why I feel comfortable saying that we can do this. One is that Google's done it at scale. And the infrastructure that we actually use internally to do this is not overly complex. The second thing is, we've run a lot of performance benchmarks in terms of, what does it take to distribute key material, rotate key material, actively revoke key material, and how expensive are these kind of tunneling protocols. And as compute power has evolved, and particularly as the modern processors have evolved to make TLS, right, part of the hardware platform, right, because of the web and mobile and all these other things, that overhead is actually very, very small. The other part is amortization. Who's willing to pay the cost, right? If you can amortize the cost by putting it next to the workload or in the workload itself, effectively, then it doesn't become this big centralized cost. It doesn't become this one big thing you have to buy. right? Often what you'd see is, an IPsec tunnel, but there'd be some big thing terminating IPsec, bridging into a network and beyond, and you'd pay a big fixed price for that one big thing. This doesn't do that, right? So that cost is distributed among everyone else in the network, right? They're all participating as peers. And so that has a big effect on the dynamics of the system. Sure, yeah. But in some of the CPU costs particularly, you can drive ASNI and Intel processors faster than you could drive the network today. Okay. Oh, one minute?
So one of the things Google has been advocating in the IoT space was this hardware-rooted trust in a chip, like microchips, chips. Is it in the same direction of end-to-end TLS and key rotation, key management at the hardware level, or whatever you're talking is only in the container space and in the services space that's living in software?
No, this paradigm is general purpose, right? I mean, Istio is obviously an infrastructure designed to make it easy to consume in the kind of classic data center world, but the same basic principles apply everywhere. Probably the good equivalent in the data center would be TPM, right? Where key material is managed in a secure, right, resource that's hard to break into. One of the things you'll see in the kind of Linux community and also in things we do in Istio is we don't actually have to expose the key material to the application or put it in exactly the same trust domain as the application, right? You can delegate the PKI exchange parts of TLS into something like a TPM. So the application would only ever see, the ASNI part of the post-PKI aspects of the cryptographic protocol. Right, similar to SEM modules that run on phones or other things like that. And then they underneath could have their own mechanisms for, doing key material management for PKI or some other system. Right, so really that's about preventing, applications being exposed to, injection attacks, being able to compromise key material that then they could take and use elsewhere, right? That's what those systems are primarily about. And so this is complementary to that, and we've had a number of conversations. Well, it's not something we do in the current version. Got one here?
Good morning. Help me understand the context of workload ID. If I am a workload and I'm trying to present myself, somebody's thrown me the conch. I'm holding the conch now. If I'm trying to present my credentials to the system as a service that's worth being communicated with in a mutual identity architecture, there are a number of things that can pass for quote unquote workload in a layer 7 architecture. I can be an application, I can be a container, I can be a service, I can be a function. And in a situation where you've got functions that are built to be functions and built to be used by multiple applications, there's all different types of layering going on. So if I'm identifying myself as a credentialed workload, what does that mean?
So I think there are a few different things, right? So obviously there's a continuum of identity, right? The one other thing you didn't mention was people, right? But all those things are workloads, right? If it's a piece of code running in your network that wants to communicate with something else, it's a workload, right? Doesn't matter how big it is, how fast it is, where it is, who owns it, that's what it is. So we as a platform obviously have to support that, ranging from mobile apps to other things. The other thing to consider is the notion of layered identity, right? Most workloads do things on behalf of other workloads or people, right? And there probably should be some trust model that represents that as work flows through the system. Mostly what happens today in systems, you see API gateways, right? I receive a request from an end user and an OAuth credential. I validate the OAuth credential. I probably pass it down through the system. And that is basically an assertion saying that it's allowed to perform an action on behalf of that person. as that credential flows through the system. It's not usually an assertion that says they're allowed to perform that operation on behalf of that person because it came through service X. And that's also a security problem, right? You need to have both, right? Trust should get narrower the deeper into the network you get, right? User credentials presented at the edge tend to be extremely powerful, right? And if you just propagate them internally in your network, if any one system is compromised and steals that information, it can impersonate that person to perform any other operation that credential would nominally have presented, regardless of where that work is coming from, which is a big problem. So, I'm not going to, we didn't do slides because I had a limited amount of time, but we also want to help people solve the problems of layered identity and downscoping as work transitions through the network. That's a harder problem, right? Because you really have to start opening the tin of tuna sometimes, the tin of herring, to kind of deal with propagation. But you can do some things at layer 7 that help with this problem. And you can certainly write policies that constrain who is allowed to present what type of credential in what scenario. Right? But usually user credentials are propagated at layer 7, not at layer 3, so you have to deal with that too. All right?
Super.
Thanks for joining.
Thank you very much.